Hello, everybody. My name is Captain Kyle Palco. I am an AI researcher with the Air Force MIT AI Accelerator here in Cambridge, Massachusetts. I'm talking today about the Air Force Arcade, which is deep reinforcement learning using Unity on the Lincoln Lab supercomputer. A quick overview of the project. Guardian Autonomy for Safe Decision Making is a collaboration between MIT Lincoln Labs, and the US Air Force. And what we're doing here is creating a sim to software in the loop to real pipeline for autonomous control agents. We want to basically train via deep reinforcement learning on a custom three-dimensional control environment, continuous control environment. And we selected Unity because it sits on the intersection of robotics, machine learning, and computer vision, and allows for rapid development of these custom low-fidelity simulation environments. Overall, this pipeline, we took the TensorFlow models developed in our custom Unity environments, pushed them to AirSim in Unity, which is a higher fidelity software in the loop environment, finally to a real quadcopter for final testing and validation. The Lincoln Lab Supercomputing Center, which I'll refer to as SuperCloud, provided this support where we actually didn't really know if this was possible at first. Unity has a few limitations, namely that they don't know, or they no longer support cloud environments. So we took a couple of different documentation that they had on their GitHub site and basically said, well, let's hope this works. It also requires a rendered environment to be pushed to displays to actually train on visuals. So you can't just do the calculations without pushing to a virtual display, which was new for me in a supercomputing environment. Finally, it's CPU locked and has high computational requirements, which really limited the number of training events that we could do on our local machines. So SuperCloud helped us by virtualizing our display monitors, and then also with multi-threading, because the Unity games that we created had a very difficult time of actually using the proper CPU threads. As a result, we saw a significant decrease in training time per model, and almost 12 times the number of total training steps that we were able to experiment with compared to running it on our local machine. Being able to move our resource hog training environment to the supercomputer allowed for continuous development on 3 separate local machines, which I think, this whole pipeline is essential to something that's scalable and reproducible. Otherwise, we would have to say, let's try and figure out how to push our development and train it overnight or over the weekend when we're not actively using our laptops. Being able to continuously push the supercomputer allowed us to work on other work in parallel. For our impact, what we actually saw at the fundamental baseline is that deep reinforcement learning on complicated scenarios is just not feasible on our local machines. For reference, DeepMind AlphaStar, which is the model that was trained to play StarCraft at a superhuman performance, required over 405,000 hours on a TPU v3. If you tried to equate that to running on a local development machine, a local laptop, it's just not possible. It'll take you forever. So the supercomputer really enabled our AutoFly RL pipeline. We saw 12 times the number of model iterations and experiments that we were able to run. In reality, that's probably 2 or 3 times more, just due to the fact that our local machines were no longer tied up with training. We could do parallel developments and other work that was required instead of having just to wait to train overnight. This proof of concept to use distributed compute for high fidelity graphical environments has really opened the door for us to use this more in the future. And we've already provided, or actually worked on, some new optimizations where we've seen significant decreases in training time requirements down to like 80% less of what we have now. So we're very excited to work with Lincoln Labs and the Supercomputing Center in the future.